This is video number 17 on Foundations of Arithmetic, Algebra, and Graphing, with a focus on real-life interpretation and application, though in the last video I focused pretty much purely on computation. I'm going to continue that a little bit in this video, but I will get to an application, I think. So this is Arithmetic of Rational Numbers, also known as Fractions, Part 6. And here was the example from the last video. It was a big long calculation involving prime factorizations. And I did check, after I finished this video, I did check that this was correct. I did not make any mistakes. I could just double check all the calculations that I did here, but I could also use my calculator, and these fractions both turned out to be about 0.189 when you use your calculator to do this calculation for you. I want to show you, I did emphasize this in another video, I want to show you that you don't have to do the prime factorizations as I did to simplify that calculation by hand. You could instead just focus on doing cancellation as you go, and that is going to be a little quicker than using prime factorization, though I may not have left myself enough space here. There's going to be lots of cancellation that goes on. For example, I can cancel the 800 with the 2520, divide them both by 2 to get a 400 over 1260. Then I can cancel the 400 with the 1260, divide them both by 2 to get 200 over 630. Continue dividing by 2, 100 over 315. Now I have to divide by 5, because that's no longer even. 5 goes into 120 times, into 315, and we saw it goes 63 times. And let's see. 20 is 2 times 2 times 5, 63 is 3 times 3 times 7. Those no longer have any common factors. That first fraction can be reduced to an equivalent form, 20 over 63, and can't be reduced any further. How about this next one? Both divisible by 2 here. 5250 divided by 2 is 2625. 8820 divided by 2 is 4410. That's no longer divisible by 2, but it is divisible by 5. Let's see, we found it to be 500 and... I forgot. Let's see. That was 2225, so that would be, when I divide that by 5, that'll be 525. This divided by 5, again, 5 goes into 4,000. I'll go 800 times into 400, it goes 80 times. 882. Let's see, is that right? It's 4410. Just trying to double check things in my head. Yes, that's right. This is no longer divisible by 5 there, but these are both divisible by 3. If you add their digits, you get multiple of 3. 8 plus 8 plus 2 is 18, which is a multiple of 3. 5 plus 2 plus 5 is 12, which is a multiple of 3. I can divide these both by 3. 525 divided by 3. Let's see, 150 times 3 is 450. Another 25. Looks like we have 175 when we divide that by 3. This divided by 3, 900 divided by 3 is 300. This is 18 smaller than 900, so that I'm going to get 294 there, 300 minus 6, since 18 divided by 3 is 6. Oh, let's see, any more? I think there maybe were factors of 7 here, though that's hard to tell. 7 goes into 140 evenly, and there's 35 left. 175 is 35 above 140. So that 7 goes into that. 7 also goes into this because it goes into 280 and also 14. So 7 into 175 again is going to be 25. And 7 into 294 is going to be 42. 25 is 5 times 5. 42 is 2 times 3 times 7. No common factors there. Those are as reduced as they can be. The reduced form of that is that. Before I do this multiplication, I can continue canceling some more. I can do some, you might call it cross-canceling. The 20 can cancel with the 42 to leave 10 over 21. Anything else cancels. 2s and 5s are the factors up there. 3 times 7 there. 63 is again 3 times 3 times 7. So we got no more common factors. All right, this is as far as I can go. Now I multiply 10 times 25 is 250. And I recall from the last one, 63 times 21 is going to be 1323. And maybe you want to work on doing that in your head. I know I've gone real fast here. So you probably want to pause the video if I was going too fast for you and try to redo all this on your own. And maybe from the last video as well, you might want to re-go over that one and try to do it all on your own. You can see this was ultimately faster than the prime factorization approach. They do essentially mean the same thing, but that's a faster approach. All right, let's look at an application, and I'm not going to be able to finish this in this video, I think, but just sort of get a hint at what to do, and we'll finish it in the next video. Pie again. I cut French silk pie, my favorite kind of pie, into 12 equal pieces. On the box it said a serving was 540 calories, and that a serving was also 1/8 of the pie. So I'm cutting mine into 12 pieces. Each piece is going to be less than a serving then. How many calories was one of my 12 pieces? First of all, you should say to yourself what I just said. Since I'm cutting more pieces, each of my pieces, my 12 pieces, is going to be smaller than the 8 pieces that the box is sort of recommending, you might say. 1/12 is less than 1/8. So, because of that, the calories in my one piece is going to be smaller than 540. That's the first thing to realize when you think about a problem like this. How much smaller? Let's see if we can get a hint about what to do here. And I would, again, I guess, recommend drawing a couple pictures. 2 circles that represent the pie. I guess we only have one pie here, but I'm drawing it twice because I'm going to break it up into 2 different ways twice. Let's do it 8 ways first. So that's the way the creator of the pie is recommending for the piece size, the serving size. Breaking it up into 8 is pretty easy. First break it up into 4 pieces and then break those pieces in half about like this. So you got to pretend that these are all the same size, 8 equal pieces. Breaking into 12 pieces is a little trickier. I'd first break it into half. And then each of these halves I would break into 3 pieces first to get that'll be 6 total pieces. You got to kind of eyeball angles of about 60 degrees here, and that's tough. Of course, this is not perfect. So now I'm pretending, oh, that looks too big, but pretend I've got 6 equal pieces here, then I cut these in half again to get 12 equal pieces. Use your imagination to pretend that. All right, so what I'm going to eat is one of these 12 pieces. Let's just pick this one. And I want to know how many calories are in that 1/12 of the pie when I know there's 540 calories in that piece, which is a little bit bigger than this piece. It's not twice as big. It's not, twice as big as this piece over here would be 1/6 of the pie, which would be bigger than 1/8. So the answer is not going to be half of that. It's not going to be 270. It's going to be bigger than 270. It's not going to be halfway in between necessarily. Be careful. It's not going to be halfway in between 270 and 540, but it will be between them. I'm going to stop the video here now. I'd like to encourage you to see if you can figure out the answer to this question on your own, maybe thinking about this picture or maybe doing a calculation, and we'll finish this in the next video.